It's Tuesday, the 14th of August, 2018. My name's Juan Brown. You're watching the Blanco Lirio channel, and it's time for an Oroville update. Two interesting breaking bits of news. Oroville Dam Boulevard East is now open to the public. So now you can get down to the bottom of the Oroville spillway across the river from the Dentates and get a good view of the spillway. The turnouts on the road are available for parking and viewing of the spillway. Also, yours truly has been invited once again to come back down to Oroville for a boots-on-the-ground report with the video camera of the progress to date at the Oroville Spillway. We're still working out, trying to coordinate the dates between my day job and Kiewit Engineering, but we'll look for that update soon in September. Between all the smoke and heat from the forest fires and my flying at my day job, I've been unable to take the mighty Luscombe out for this particular update. However, Oroville has provided, or Department of Water Resources and Kiewit Engineering have provided some great aerial drone footage today that we're going to look at for the progress at the Oroville Spillway, proving that given the right circumstances, the state of California can still do massive infrastructure projects on time. First up, by popular demand, a great comparison video showing the construction to date from July of last year to July of this year of the main spillway. Starting at the bottom of the spillway over the Thermalito diversion pool, work continues on rebuilding the original Dentates. And here's what it looked like last year, just getting the leveling concrete in place. The Dentates are diffusion blocks, of course, to help disperse the water as it falls into the Thermalito diversion pool. And the shipping containers you see above the Dentates are to stop any loose equipment from tumbling down into the construction crews working on the Dentates. Here we can see the leveling concrete and trenches for the drains from a year ago. Now as we approach the second plunge pool, we can get an idea of just how much roller compacted concrete was used to fill that plunge pool. And all this bedrock was cleaned and scrubbed by hand to ensure a good bond. Dental work, they call that. Here's the structural concrete slabs and walls going in place over the RCC section of the spillway. Remember, the RCC was used temporarily to create the spillway for last year's flood season. Now approaching the main plunge pool, that point where the spillway initially broke, you can see just how deep 150 feet worth of canyon is that needed to be filled by RCC. And here's the structural panels going in place on top of the RCC above the upper plunge pool area. And here's what the edge of the old spillway looked like a year ago. Here where the original spillway failed, primarily due to lack of proper drainage and water creeping underneath the cracked old spillway and blowing it out, the spillway also takes a rather steep turn downhill to a steep 4-to-1 slope. The new structural walls and panels in this upper portion of the spillway that they decided to rebuild last year after unauthorized blasting damaged some of the original spillway. And here's what's going on last year underneath that structural concrete, leveling concrete and drains. And finally, the last section of original spillway leading up to the gates being removed and replaced this year. Great job, DWR, putting this composite video together showing us the construction year to date from July of last year to July of this year, 2018. Now let's go look at some great DWR drone footage posted on 1 August 2018 of the work that's going on Phase 2 of the emergency spillway. Now check out this interesting roller compacted concrete design of the main low point, the second low point in the emergency spillway. Remember, this is where the majority of the erosion took place in the emergency spillway, and where this erosion began to eat back towards the OG weir and caused the evacuation. In fast forward, you can see how the RCC is applied in a 24/7 operation continuously, 15-inch lifts compacted down to 12 inches. Generally speaking, there is no steel reinforcement inside this roller compacted concrete. However, here at the secant cutoff wall at the edge of the emergency spillway, some steel reinforcement is being applied in preparation for the buttress wall that'll make the final transition from the emergency spillway to the earth and hillside below. The green color of the steel is an epoxy primer designed to prevent corrosion. This structurally ties in the tie wall, on the square wall on top of the secant cutoff wall, with the rest of the RCC splash pad. Work will continue on this emergency spillway beyond the November 1st, 2018 deadline to have the main spillway completed. Here's that tie-in wall that stabilizes the top of the secant cutoff wall, and here you can see the very tops of the round steel reinforced tubes that make up the secant cutoff wall that extend almost 80 feet down to solid bedrock below, all in an effort to prevent head-cutting erosion from ever impacting the emergency spillway OG weir again. Once the portable RCC plant is removed, these two low points on the emergency spillway will direct the water down two natural canyon waterways on the hillside below, if in the unlikely event the emergency spillway is ever used again. And finally, from video posted on 9 August 2018, we see crews working on the main spillway, completing all the structural panels that need to be in place before the November 1st deadline. So with outdoor air temperatures exceeding 100 degrees Fahrenheit daily here on the Oroville project this time of year, how do you maintain the delicate balance of temperature control of your structural concrete to prevent it from firing off too soon, and at the same time achieve the required level of strength? Liquid nitrogen. Truckloads of liquid nitrogen injected into each load of very carefully controlled, temperature-controlled structural concrete, plus a giant chiller or cooling plant at the structural concrete plant. All works to keep your structural concrete the correct temperature while operating in these hot conditions. Each batch checked. And from the structural concrete plant still located on the old boat ramp above the emergency spillway, the concrete is transported over to the main spillway, loaded up into the pumping rigs, and pumped in to the structural forms. Note also the haul road has been changed so that trucks no longer have to drive over the gate structure at the top of the spillway and instead use the new road on the north end of the emergency spillway. Good work, gentlemen, and be careful. The folks at Kiewit Engineering and Department of Water Resources proving that the state of California can still get massive infrastructure projects done on time.